So, the analysis can be of two types. Number one, which is a qualitative analysis. Number two, which is a quantitative analysis. Now, qualitative analysis gives us the identification of a compound, while quantitative analysis gives us the amount of compound or the amount of a particular substance present in our mixture or in our sample. Right? Here we will call our substance as a sample, because each and every instrument handles the identification or the identified substance as a sample. It can be of any form. It can be a solid, it can be a liquid, it can be a gaseous one. It can be semi-solid ones also. Okay? So depending upon that, we will utilize the analytical techniques here. Here, in this particular session, we will learn about mass spectrometry. The short form of it is MS, or it can also be known as mass unity or mass also. Okay? So here, in the picture, you can see the mass instrument. Mass spectrometry is a method that is used to identify different substances within the taste sample. Okay, here you need to remember that it is mass spectrometry and not mass spectroscopy, because spectroscopy involves the study of the sample with the use of light, how the light interacts with the sample. But in spectrometry, we will not use light. We will measure the mass of the particular substance or a particular molecule in the sample or in the taste sample, and because of it, it is known as spectrometry and not spectroscopy. You need to remember it properly. Okay? So, here, mainly it includes the identification of the fragments. Okay, the mass to charge ratio of the fragments of the compounds. The first thing and the foremost thing for mass spectrometry is that we have to fragmentize our compound, and after that, that particular fragment will be identified, right? So how the identification is possible? Now we all know that each and every substance or each and every compound is different. That means it's an individual. So when we fragment them or when we break them at that time also, the fragments are also different, or they are totally individual of that particular compound. Right? So as the compound is different, the fragment is also different, or one fragment can be possible for one particular compound only. And this is the base of the identification of the compound from mass spectrometry or by mass spectrometry. Let's understand it with the help of the example here. Now we have taken the example of methane. So methane produces a parent peak, that is mass to charge ratios peak at 16, and in the fragments of 15 and 14. How it's possible? So as you can see here, CH4 is divided or is bombarded with the electrons, right? In further slides, we will see that how the ionization will be done. So it is bombarded with the electron. So by bombarding it with the electron, it will convert itself into two different fragments. Number one, CH3 plus, and number two, CH2 plus. Okay. So in the first one, we will have CH3 plus hydrogen radical. While in the second one, we will get CH2 plus 2 hydrogen radicals. Okay. So the first one has mass to charge ratio of 15, while the second one will have mass to charge ratio of 14. These two fragments are identical of methane. It's not possible for any other compound. Okay. So in this manner, this fragment gives the identification of our particular compound. Now, let's observe the principle of the mass spectrometry. It is divided into three different parts. Number one, ion formation. Number two, ion separation. And number three, ion detection. So all these things generally moves around the ion. What do you understand by ion here? The fragment, which is ionized. Okay? So for ion formation, we will have different techniques like chemical ionization. So we will bombard our compound with any other particular chemical. We have electronic ionization. That means we will bombard our compound with highly or high speed electrons. Along with that, we have here MALDI. What is the meaning of it? So matrix assisted laser desorption ionization. That is MALDI. That is one technique to ionize a compound. So after the formation of ion, what we will do? We will do the separation of the ion. So with the help of the ion separator. Which are the ion separator? They are also known as quadrupoles or mass analyzers. Right? We can use grating, we can use prism, etc. for the ion separation. After the separation of ion, we will have the ion detection. How? With the use of mass to charge ratio. For that we can use PMT, we can use any other detector also, but generally photomultiplier tube detector is widely used. Okay? Now, in this particular part, we will learn about that how the analysis can be done with the use of mass. So, as you can see here, first one includes sample. So the sample enters into our instrument. After entering, the electron beam source is there, which will bombard our compound with the electron beam. After that, the ionization occurs. After the ionization occurs, the ions are accelerated. Okay? After that acceleration, they are moved or they are actually allowed to pass through the magnetic field. And at that time, the deflection occurs. How the deflection occurs? Depending upon their mass to charge ratio. If a compound has more mass to charge ratio, then it deflects in a different way. Likewise, the fragment which has less mass to charge ratio, then it deflects in a different way. The speed along with its mass or its deflection is the identification. As it reaches the detector, we will get the graph, which is known as mass spectrograph or mass spectrometer here. One side includes abundance, second side includes mass to charge ratio. And depending on that, the peaks gives us the identification of our compound. So, the instrumentation, right? Now, first one includes init, that means the sample introduction. After the sample introduces, it goes through the vacuum pumps. The whole environment is under vacuum, in which first one is the source. That means the compound is converted into gaseous phase. After that, it is bombarded with any other electron or any other part. It is ionized, then moves to the analyzer, which gives us the ion separation. After that, it moves to ion detector, which will detect the ions or which will detect the fragments. Afterwards, it reaches to the data system, which analyzes all this data and gives us the graph, which includes abundance versus mass to charge ratios graph. It is known as mass spectrum. Okay? Here, as we have seen, that contains three different things: capture, accelerate, and deflect, and detect the ionized molecules separately. Okay? We will use here the fragments for the detection of the compound. Okay? So here, next one we will have is types of mass spectrometer detector. Okay? So generally we have GC along with mass. So we will use it, and here it is also known as MSD, mass selective detectors. Along with that we can use TOF, time of flight, and MSMS also. That includes triple quadruple system. Okay? Let's move on to the next point, and which is applications. Qualitative and quantitative analysis of low polarity compounds can be possible. Along with that, analytical chemistry, biochemistry, petrochemical industry, and environmental monitoring also has a particular part of mass. It can basically detect compounds at nano levels and even at pico levels also. It is used to measure any toxic substance in soil, air, and water. That means it is used to identify any pollutant or any toxicant present in all these samples. Along with it, it also used in criminal forensics. That means to identify any substance found on the crime scene. So we will use mass for all these kinds of applications. So as I have seen that here, we can use it in law enforcement agencies like to detection of the illegal narcotics, in forensic toxicology, in sports for anti-doping analysis to detect certain banned substances. Even it is used for the explosive detection also. Right? Along with that, food and beverages and perfumes, that kind of industries also involves the analysis of the substance using mass. And last but not the least, it has a wide application in medicine field, which generally gives us the identification of the by born or by birth metabolic diseases, and it gives us help in find out which kind of diseases there. This is all about mass spectrometry. Next we will learn in our next session. Thank you everyone.